Solving linear systems by substitution. Substitution is another method for solving a system of linear equations. We have already learned one method, which is by graphing. Now, we've also learned how to use our calculators for graphing, but the overall method that we've learned is just graphing. By the end of today's lesson, you will be able to use substitution to solve a linear system. So let's take a look at example number 1. Our system is y equals 1 plus x and 2x plus y equals negative 2. In step 1, the goal is to pick an equation and get one variable by itself. Now it doesn't matter if it's x or y, but in this case, we already have one equation that already has y by itself, which is our top equation. So here you see it written again, y equals 1 plus x. What we're saying here is that the value of y is 1 plus x. So we can take that value and plug it into our other equation where y would be. So if you notice, in the equation 2x plus y, which I'm now rewriting here, instead of writing y, I place my brick, which is 1 plus x. And I'm going to go ahead and simplify this problem. 2x plus x is 3x, plus 1 equals negative 2. Subtract 1 from both sides. We get 3x equals negative 3. Divide both sides by 3, and we get that x equals negative 1. So now that we know what x equals, we can take that value and plug it back into where our brick is, because that's asking us to solve for y. So y equals 1 plus x, which we now know is, whoops, that should be a negative 1, not positive. Negative 1, and I'm just going to scroll down for some space. I know when I plug in negative 1 that y equals 0. So our solution to this linear system is negative 1, 0. Alright, let's go ahead and take a look at example number 2. In example number 2, our equations are x minus y equals 2 and y equals 2x plus 1. I am going to choose the bottom equation because y is already alone. Again, I'm saying that the value of y is 2x plus 1. So I'm going to take that value and I'm going to plug it into our other equation. So our other equation, being the top one, is x minus y equals 2. But like I just said, I'm going to take the value of y, which is my brick, and plug it in. So now we have x minus our brick, which is 2x plus 1, and that equals 2. And we're going to simplify. Now it's important to understand that our brick also represents parentheses. So right here we have a negative that we need to distribute. So we have x minus 2x, but then we have to distribute the negative to the 1, so it becomes minus 1 equals 2. If I simplify, I get negative x minus 1 equals 2. Add 1 to both sides. And when we do that, and I'm going to go up here, we get negative x equals 3. Divide both sides by a negative 1 because we want x to be positive, so x equals negative 3. Now that we know what x is, we can go ahead back to our equation where the brick was, which was y equals 2x, and I can take my x value, which is negative 3, and plug it in for x. So we get y equals 2 times negative 3 plus 1, which is y equals negative 6 plus 1, which is y equals negative 5. So the solution to this linear system is -3, -5. Remember, you always write a solution to a linear system as an ordered pair x, y. Okay, let's go ahead and do some more practice. Alright, number 1. Here's our linear system. 3x plus y equals 9 and y equals 2x plus 4. I'm going to choose the bottom equation, y equals 2x plus 4, since y is already by itself. So I'm just going to write that. Y equals 2x plus 4. So again, I'm saying that the value of y is 2x plus 4. I'm going to take my first equation, or the other equation, which is 3x plus y, which I can now say is 2x plus 4, and that equals 9. So again, I've taken the value of y and I've plugged it into the other equation. So let's simplify this. 3x plus 2x is 5x, plus 4 equals 9. Subtract 4 from both sides. We get 5x equals 5. Divide both sides by 5, and we get that x equals 1. Okay, now that we know what x equals, I can go ahead back to the equation where I started with my brick, and I can go ahead and plug in x. So y equals 2x plus 4, but now I know that x is 1. So y equals 2 times 1 plus 4. And if I simplify this, we get 2 plus 4, which is 6. So the solution to this linear system is 1, 6. Alright, let's go ahead and move on to number 2. I'm going to clear this drawing. Okay, 2x plus 2y equals 3 and x minus 4y equals -1. Now if you notice, in this example, we don't have any variable that has already been solved for, so we have to pick a variable. You always want to pick a variable that has a positive coefficient of 1. And the reason we do this is because then there's fewer steps to get the variable by itself. If I look at the two equations, I notice that this variable x has a positive coefficient of 1. So we're going to go ahead and we're going to pick, okay, here we go. We're going to pick the bottom equation and solve for x. So I have x minus 4y equals -1. And we're solving for x, so we're going to add 4y to both sides. And when we do that, we get x equals -1 plus 4y. Okay, so here I'm saying that the value of x is -1 plus 4y. We're going to go ahead and take our other equation, and that is 2 times x, which we now know is -1 plus 4y, and that's plus 2y equals 3. Now again, remember that our brick acts as parentheses, so we have to distribute. -2 plus 8y plus 2y equals 3. -2 plus 10y equals 3. And I'm running out of room, so I guess I'll just go here. Let me rewrite that. -2 plus 10y equals 3. We're going to add 2 to both sides of our equation, so we get 10y equals 5. We are going to divide both sides by 10, so that we get y equals 1/2. Okay, now that I know what y equals, I'm going to go back to where my x equals equation was, and I'm going to plug in y. So I have x equals -1 plus 4 times y, which I now know is 1/2. So I plug that in, and we get x equals -1 plus 2, and we get x equals 1. So the solution to this system is, oh, they're both a half. X is 1 and y is a half. All right, so there is your solution to this linear system. All right, that got a little messy. We kind of had to squish the stuff together. Let's go ahead on to the next example, number 3. Okay, again, we don't have a variable that's by itself. If I look at my two equations, I notice right away that in the bottom equation, there's only one step needed to solve for y. So I'm going to go ahead and start with that equation. 5y equals 15, and if I divide both sides by 5, I have already solved for y. Y is 3. So in the other equation, I'm going to plug in 3. 3x minus my y value, which is 3, equals 0. And we're going to add 3 to both sides. We get 3x equals 3. Divide both sides by 3. And we get that x equals 1. Now this problem had a lot less work. Our solution is already here. We know x is 1. We know y is 3. So our solution to our linear system is 1, 3. All right, that one wasn't so bad. Let's go ahead and look at number 4. In number 4, I am going to choose, well actually it really doesn't matter. We could choose the top equation or the bottom equation because they already have y's that both have a coefficient of positive 1. Let's go ahead and start with the top equation. So that is negative x plus y equals 1. And we're solving for y. So we add x to both sides. And we get y equals 1 plus x. Again, now that I know that the value of y is 1 plus x, I can take that value in the other equation. So we have 2x plus y. That's where our brick comes down, which is 1 plus x, and then that equals negative 2. So we're going to simplify this. 2x plus x is 3x plus 1 equals negative 2. Subtract 1 from both sides. 3x equals negative 3. Divide both sides by 3, and we get that x equals negative 1. Alright, now that we know that x equals negative 1, I'm going to go back to the equation where y was by itself. So y equals 1 plus x. But now I know that x is negative 1, so I can write y equals 1 plus negative 1, and y equals 0. So our solution to this linear system is negative 1, 0. Alright, let's go on to our last example, number 5. I'm just going to get rid of some of this writing. Okay. Now if I look at these two equations, I'm going to choose the bottom equation and I'm going to solve for y. Remember, you picked the variable that has a positive coefficient of 1. Okay, so I've got 7x plus y equals negative 8, and we are solving for y. Subtract 7x from both sides, and we get that y equals negative 8 minus 7x. Okay, now we're going to take the other equation and negative 2x minus 5y, but I know that y is negative 8 minus 7x, so I'm going to write that where y would be, equals 7. And remember that our brick is also the same thing as parentheses, so we have to distribute that negative 5. So we have negative 2x plus 40 plus 35x equals 7. Combine like terms, negative 2x and 35x is 33x, plus 40 equals 7. Subtract 40 from both sides. We get 33x equals negative 33. divide both sides by 33, and we get that x equals -1. Now again, once we get here, we want to go back to the equation where y was by itself, and we want to plug in the value of x. So we now know that x is -1. So let's go ahead and plug that in. -8 minus 7 times x, which we now know is -1, and we can simplify this. -8 plus 7, and that gives us -1. So our solution to this linear system is -1, -1. Alright, now that we have finished our practice on solving linear systems using substitution, go ahead and see Mrs. Wilkin for what to do next.